Everyone, so today I'm going to be making a video on all of the topics that we went over last class. And so here we go. So the first thing we're going to go over is this equations and solutions section. Now, this section is most important for when you need to check your answers. So in regards to how important this lesson is, this is probably not as important as the next lesson. However, for accuracy, checking answers is really important because, sometimes you might make a mistake and you're not really sure. You don't want to do everything all over again just to check. So checking solutions is a fast way to just say, okay, did I do it right? Did I do it wrong? So the first thing we're going to do here is I'm going to look over here. It says x plus 9 equals 15, where x equals 6. Okay. So right here, we have this equation, and they give us a possible solution. Now, this x value doesn't necessarily have to be true. They're just saying, hey, x equals 6. That could be correct, that could be incorrect. Your job is to find out whether or not that's correct. Now, the first thing we need to think about here is, what is x? What is a variable? What's the job of a variable? Well, the job of a variable is to just be a placeholder if there's a value that you don't know about. For example, if I give you a stack of money and I say, how much money do you have? You don't really know how much money you have, but you do have a stack of money. So you know that that stack of money represents money, but you don't know how much. Same thing here. You know that this x represents some number. You just don't know what the number is yet. That's why we put a variable. Now, if I told you, okay, that stack of money equals 6. Sure. So that could be true. That could be not true. And the easy way to check is to count. But in this case, the easy way to check is to just plug it in. Assume that they're telling the truth. So here, what we're going to do is I'm just going to plug in a 6 where the x was. Nothing else has changed. Instead of an x, I put a 6 because before I didn't know the value, now I do know the value. So I'm plugging it in and I work it out. So 6 plus 9, that does equal 15. Now, this is what I'm looking for right here. Pretty much if the left side of the right side of the equal sign are the same, then the solution is correct. Okay, so what's happening here is we are just checking if once we solve it out, does it actually give us 15? Because it's saying here that x plus 9 is 15. Awesome. Does it actually equal 15? If so, yes. If not, then no, it's not a solution. So that's what we're doing here. When you're solving equations in the next lesson, you might have done it right. You hope so, we hope so, but there should always be a way to check your work. Now, doing the same problem twice is not helpful. It's going to take too long. So instead, when you solve for your variable and you get some solution, you're going to take that solution, plug it back into your equation to see if both sides are equal. And I'll go over that more again as we get there, but that's pretty much what you're going to do to check. So if I say check your answers, this is what I'm asking you to do. You're going to take your solution, you're going to put it back into the equation, replace your variable with whatever solution you got, and then work it out and see if you end up with the same answer on both sides. That's pretty much all of 4-1. I'm not going to spend too much time with it. There's not really much to go over. I'll do another problem. For sure, I'll do another problem. It's the same thing every time, and we can do more practice in class. This is just not the top of the list when it comes to important lessons. So let's try another one. So we have 5. I'd rather use black. Here we go. So we have 5 equals t minus 4, where t is equal to 11. Awesome. So here they told us that t is equal to 11. So what I'm going to do here is, instead of putting t, I'm going to put 11. Then I work it out. So 5 is equal to, and then 11 minus 4 is 7. Now right here, the left side and the right side are not the same. Therefore, this is not a solution. Okay, I'm looking for the left and right side to be the same. If they're not the same, it's not a solution. If they are the same, then it is a solution. That's pretty much it. So when you get to this point, the only things you need to think about are, okay, I'm just going to plug this into the variable, solve it out. If it's the same on left and right, it's a solution. If they're not the same left and right, it's not a solution. And that's pretty much it. Now, here's the part that might be a little bit tricky. Solving equations. So in this one, they already gave you the solution, or they gave you a possible solution. In this one, they're not going to give it to you. You actually have to solve it out yourself. Now, the way we're going to do that is we are going to use something called the addition property of equality and the subtraction property of equality. And I'll kind of go over what those mean. They pretty much mean the same thing. It's just that one's addition and one's subtraction. But like what I went over in class, oh, here comes my amazing drawing skills again. So here, oh, actually, you know, that is not horrible. It's not great. It's not horrible. So this is a scale, right? It's one of those balanced scales thing where you know if they weigh the same, if it's balanced, but as soon as it starts to tilt to the one side or the other side, then you know it's not balanced. Well, this equal sign means that the left value and the right value are exactly the same. So if I wrote x and plus 2 and then 7, they should be equal. It should be balanced because that's what the equal sign means. They're the same. They have the same value. They have the same weight. Now, when you're solving for a variable, your goal is to kind of just make that variable alone. You want to get everything that's not the variable out of there so that all you're left with is your variable. So if I were to break this into my terms, and if you need me to go over how to break up terms, pretty much as soon as you see an addition or subtraction sign, you stop, and that's the start of the next term. So right here, I did up to x, I saw addition sign, I stopped, did my next term, stopped because that's the end, then that term. So those are the three parts. So this and this together on the left side, and this together on the right side. Now, I want to get rid of this term because it's not my variable. I want my variable to be the only thing on my left side. So I'm going to get rid of it. Now, how do I get rid of plus 2? Well, if I want to cancel it out, I want to do the opposite of whatever it was doing, minus 2. Because if I plus 2 and then I minus 2, it's just like nothing happened. Like if I gave you $2 and then I took away $2 from you, it's like nothing happened, right? You're back to 0. You didn't lose any money. You didn't gain any money. So that's what I'm going to do here. So I'm going to minus 2, and that's going to just get rid of this plus 2. So all that's left is the x. However, remember, these things were balanced before. If you just took something from the left side of the scale, but not the right side of the scale, they're no longer balanced. So what do I have to do? I have to minus 2 from both the sides. I have to take the equal amount, whatever I did to my left side, I have to also do it to my right side to keep the balance. I don't want the left or the right side to be heavier or lighter. I want to keep it balanced. So that's what's happening. So if I minus 2 from the left side, I'm also going to minus 2 from the right side. Then I end up with x is equal to, because that's gone now, right? That cancels, is equal to 7 minus 2, which is 5. Once your variable is alone, that is your solution. That's what you got. That's the final answer. So that means that my final answer is x equals 5. And if I want to check, sure. So here I have x plus 2 equals 7, where x equals 5. So that means that I'm going to plug in this 5 where the x was. See if the left and right sides are the same. So 5 plus 2 is 7. They are. That means that I'm correct. That is a solution. So see how everything ties together? This dark blue part is really just to check if I did things right. And this top part here is to solve when you don't really have anything to work with. You're just kind of trying to work backwards. So let's try again. Let's see, let's do x plus 9 equals 12. So again, let's think about it. I don't want my, let me see if I can move this. That works out pretty well. Okay, so I'm just going to erase this, erase that, start of a new problem. So here, this time, it's x plus 9 equals 12. So let me separate into my terms. So there's my x, there's my plus 9, there's my 12. And then I'm going to write it down here. So I have x, I have plus 9, and I have my 12. I want to get rid of this 9 because it's not my variable. My variable is x, and I need to get rid of that. So in order to get rid of it, I have to do the opposite of what it was doing before. So if I'm adding 9, if I gave someone $9, if I want to make sure that it's like nothing happened, then I want to subtract $9. And that kind of cancels it out. But to make sure that my scale is balanced, I'm going to do it to my right side as well. So I end up with x, because these cancel, equals 12 minus 9 is 3. And if I want to check, sure. So x plus 9 equals 12. And then plug in the 3 where the x is. 3 plus 9 is 12. 12 equals 12. And because the left and right side are the same, that's a solution. That's correct. Now, the rule that allows you to subtract from both sides without any issue is this rule up here. It's called the subtraction property of equality. It's exactly what it sounds like. You can subtract from both sides and it will keep the equality. It will keep things equal. Now, that's just the name for it. So if ever you see the name, like, hey, what property did you use here to solve? This is the name of the property. So this is to add to your properties list, your vocabulary, to know, hey, the property that allows you to subtract from both sides without any issue, that is the subtraction property of equality. Okay, so every time you're minusing from both sides, that's the property you're using. Okay, so now let's try this one. Let's do another one. So we got 6 plus x equals 11. I'm going to try to do it without the scale this time. I'm still going to show you the terms just so that you can see where everything comes from. Okay, now this one is a little bit tricky because it's plus x here. How do I get rid of 6? Well, let's think about it. If you have 6 of something, if you want to get rid of that 6, what are you going to have to do? Well, you're going to have to take away 6. What is take away? Take away means to subtract. So I'm going to subtract 6 from both sides. So your goal here is just to get rid of it using any method you know how. In this case, if I have a 6 and I want to get rid of 6, I'm going to minus 6. I'm going to take away that 6. So I end up with x plus x, or just x, is equal to 11 minus 6 is 5. Now let's check. 6 plus x equals 11, where x equals 5. So I'm going to plug in my 5 here. So 6 plus 5 equals 11. 6 plus 5 is 11. So 11 equals 11. Awesome. That means that this is a correct solution. You're just going to look at either the left side or the right side. It doesn't really matter which side the variable's on. But whatever is on the variable side, if it's not a variable, get rid of it. By any means necessary. So if you see like a 6 minus, oh no, maybe not minus, plus x, oh, that's the same problem. If you see an x plus 9 equals 12, I think, yeah, that's the exact same problem, equals 15, you want to get rid of the 9. If you see an 11 plus x equals 24, you're going to get rid of the 11. If you see a 32 plus a equals 50, remember a is still a variable, so and 32 is not. So you're going to get rid of that 32. You're going to take it out. Each time you're taking away whatever is not the variable. So once you identify your variable, everything that's not that, you're going to get rid of by any means necessary. In this case, we're going to be subtracting them. So now, let's do these kind of problems. So here, let's see if we have some space. Awesome. So we have y minus 21 is equal to 18. All right. So here, remember, if it's not the variable, we want to get rid of it. I saw a subtraction sign, so my term stops. All right. So y minus 21 equals 18. All right. So if I want to subtract 21 originally, if I want to get rid of that, if I took away $21 from you, what do I have to do to make it so that as if nothing happened, as if you still didn't lose any money? Well, I would have to give you $21, right? If I took $21 from you and then I gave you $21, it's like nothing happened. You didn't lose any money. So that's what we're doing here. We minus 21, and to cancel it out, to make it as if it didn't exist, we're going to add 21. But again, to both sides, because we want to keep that left and right side balance the same. So y is equal to, because these cancel, is equal to 18 plus 21. Was that 9, 3, 39? Awesome. And if we want to check if that's true, okay. So y minus 21 is equal to 18, where y is equal to 39. So I'm going to plug in 39 where the y was. So 39 minus 21 equals 18. 39 minus 21 is 18. So 18 equals 18. Left and right side are the same. That is a correct solution. This is using the addition property of equality. So it's exactly the same kind of idea as the subtraction property of equality. Let me see, I think it was over here. It's the exact same kind of idea. You can subtract from both sides for this one. This one, instead, it's you can add to both sides and it will keep the equality. You can add to both the left and the right side and it will still be an equal equation. Let's do another one. So here we got 31 is equal to g minus 16. Again, it doesn't matter if the variable is on the left or right side. All that matters is that once you identify your variable, you're going to move everything that's not that variable away. So here, there, and let me move it a little higher. There, sure. So this minus 16, that's not a variable. So I'm going to move it away. I'm going to get rid of it. In order to do that, I'm going to need to plus 16, because by adding 16 to minus 16, they kind of just cancel. But then I have to do it to the other side. So these are gone, that cancels. So g on this side, and this is 1 plus 6 is 7, 3 plus 1 is 4, 47. G equals 47. Again, if you have 47 equals g, or you switch it to g equals 47, it's the same thing. It really doesn't make a difference which one you choose. These are both correct answers. Up to you. So if I were to try that, 31 equals g minus 16, where g is equal to 47. All right. So again, I'm going to plug in 47 into where the g was. So 47 minus 16, 7 minus 6 is 1. 4 minus 1 is 3. So 31 is equal to 31. Left and right side are the same. That is a correct solution. That's pretty much what you're going to be doing every single time. There's not going to be anything different. And that's pretty much it for today. We went over how how to check solutions. So with that one, all we're doing is we are plugging in whatever solution we have, whether they gave it to us or we solve for it, and just plugging it in and working it out. If the left and right side are the same, awesome, it's a correct solution. If the left and right side are not the same, something went wrong. That's not the correct solution. Next, we learned how to solve equations by moving everything that's not the variable away. We get rid of it. We want it gone. So once we get it gone, we make sure that's the only thing left, and that's our solution. Whatever we do to the left side, we do to the right side to keep the balance of the scale. And this works for addition as well, and subtraction. Now next time we're going to be learning about multiplication and division. Same kind of ideas. You're going to be doing the same thing to both sides, it's just you're going to be doing multiplication and division this time. All right, so that's it for today, and I will see you all on Tuesday.